Okay, in this video, I want to discuss the distance formula and its relationship to circles so we can talk about the equation of a circle, just like we've talked before about equations of lines, okay? So the first thing to discuss the distance formula here, I'm going to take what's called the Pythagorean theorem, which I'm sure you've heard of before. Let's have you recall what that means. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse is the sum of the squares of the two legs. Now, the hypotenuse in a right triangle is the side that's opposite the right angle in the triangle. We usually represent a right angle by just kind of making a little square here. So in this drawing that I have, C is the length of that hypotenuse, okay? The two legs are the other two sides. Those have lengths A and B respectively there. Okay, so Pythagoras tells us that a squared plus b squared is going to be c squared in this right triangle. If you want to isolate the hypotenuse, okay, you just take square roots here. So that c, which is a non-negative number, in fact, usually a positive number, right? If you're not dealing with a degenerate right triangle. C is a positive number. It's going to be the square root of a squared plus b squared. Okay, so we want to remember this as a form for the Pythagorean theorem. Okay, now for this idea of the distance formula. Suppose that I have 2 points in the Cartesian plane, and the 2 points have these coordinates, x1, y1, and x2, y2. What's the distance between those 2 points? Okay, here I've made a little drawing, okay? It's not completely general. I couldn't do that with a single drawing anyway. But here I've got the xy plane, and I've got these 2 points with the said coordinates here. Okay. The idea is let D represent the distance between the 2 points. So we'll be using a D here for the distance between these 2 points. Go ahead and draw a horizontal line through one of the points and a vertical line through the other, like I've drawn here. Okay, doesn't matter which one you do, okay, which one has the horizontal line and which one has the vertical line, okay, but a horizontal line and a vertical line will always intersect in a right angle, okay. So the two lines will end up forming part, generally, of a right triangle, okay, with D as the hypotenuse, okay. So you see in my drawing, here I end up with what? A right triangle with D as my hypotenuse. Now I say generally you get a right triangle. Can you consider the situations where I wouldn't actually get a right triangle? Okay, and I want you to take those as an exercise for yourself. Consider those that situation or those situations and see if the formula for the distance between the 2 points that I come up with here doesn't still work. Okay, I claim that it will still work even in the case where you don't technically get a right triangle, okay, through this method. Okay, alrighty, now consider that for yourself. But generally, you're going to get a right triangle like this. Now, let's go ahead. So D is the distance between the 2 points. That's the hypotenuse. What's going to be the length of the 2 legs? Well, the length of the 2 legs is going to be the following. One length, the horizontal length here, or the horizontal leg, I should say, will have length, which is the absolute difference in the x coordinates, okay? So there you see I've got my vertical bars. I decided to go x1 minus x2, okay? And then the absolute difference between the y coordinates will give you the length of the vertical leg, okay? Now, Pythagoras would tell us that D would be the square root of the sum of the squares of the legs there, okay? Remember that form? Now, taking the absolute value and squaring it, okay, is going to be exactly the same as just squaring the difference, okay? So you see in my final boxed in answer here, D is the square root of the change in x squared plus the change in y squared, okay? I dropped the absolute value signs there because they end up being superfluous once I'm squaring, right? The square root of, the square root of z, or not square root, but the absolute value of z squared and z squared is going to be the same if z is a real number, right? Okay, if z is a real number. All right, I hope all this made sense. By the way, people will often say a change in x values, they will write it this way, delta x. Okay, maybe you've seen that sort of notation before. That's not times anything. Delta x is considered a single symbol. That's the change in the x values. The change in y values is delta y. And then sometimes people would write the distance formula this way. D is the square root of delta x squared plus delta y squared. But I hope you see there, just in hidden form, what? The Pythagorean theorem. Okay, so I boxed those two formulas in here. Let's just take a concrete example. Find the distance between these 2 points at -1, 6 and 2, 2. So D is going to be the changes in the x squared plus the change in the y squared. So that's -3 squared plus 4 squared. That ends up being 9 plus 16 squared root of 25. The distance between those 2 points in the Cartesian plane would actually be exactly 5 units, okay? By the way, it doesn't matter which one you call x1 and x1, y1 and x2, y2. Because you're taking the differences and squaring them, I could have gone, 2 minus -1 here, 2 minus 6 here, and I would have ended up with exactly the same answer. Okay, alrighty. So just make sure you're taking differences in x's and squaring and differences of y's and squaring underneath the radical sign there. All right, circles. All right, well, I hope you can see this here. I guess I didn't draw it very darkly here. But what is a circle? A circle in the plane is a set of all the points, a fixed distance called the radius from a fixed point called the center. Okay, so a circle is the set of all points, a fixed distance from the center, and that fixed distance is called the radius. Okay, now I'm going to call the center HK. Okay, remember we used HK for the vertex of a parabola? Well, here HK is not a vertex, it is the center of the circle. This is just a tradition now. And the radius I'm going to call little r there, okay? So when I say r, I mean little r. And you can see my circle here. So if I take any point xy on the circle, its distance from HK should be exactly r. It doesn't matter which point on the circle I take, its distance to the center should still be that fixed number r, okay? So I say that here, if xy is any point on the circle, then the distance between hk and xy is equal to r. Let's write that mathematically here. That would mean the square root of what? X minus h squared plus y minus k squared is r, okay? Now let's square each side to get rid of the ugly square root here, and people will often write it this way. X minus h squared plus y minus k squared equals r squared. Notice there's 3 squares here now, since I got rid of the square root. Again, that's very natural. Think of the Pythagorean theorem. When students make mistakes on this, they often forget that there's a square on the r there. No, there's 3 squares in this thing, okay? Just like what? The original Pythagorean theorem there, okay? Just like that guy. Okay. This is sometimes in my parlance. Some other people may use different language. The way I see it, I call that the center radius form of a circle. I think your book might call it the standard form or general form. I don't think that's descriptive enough, so I say center radius form, because you can see the center and radius sitting right there in the formula here. So center radius form is what I'm going to say. Okay, let's go ahead and take a concrete example. Find the center radius form of the circle with center -1, 5 and radius 7. Okay, well, you can see here the h would be -1, the k would be 5, and r would be 7. Okay, so we just have to stick those numbers in our formula up here, and then we're in business. So I've got x minus -1 squared plus y minus 5 squared equals 7 squared. Again, don't forget to square the 7. Okay? Usually with a double negative, we do simplify just a little bit and go, for example, x plus 1 quantity squared plus y minus 5 squared equals 49. So there's our answer. Don't leave those double negatives there. It's ugly. Okay, but there, we're done. So I boxed in my final answer. Okay, now something else we do. Okay, sometimes we actually multiply these things out or expand all the terms and rewrite so that 0 appears on one side of the equation. We also write it in descending order. So thusly, I will just, before describing it anymore, let's just say this. Okay, so here's another form of the circle where you've actually multiplied it out and gotten rid of the parentheses, and you have 0 on one side. Written in descending order, this is it. X squared plus y squared plus ax plus by plus c equals 0. Okay, so a, b, and c are going to be constants here. Okay, this is I like to call the expanded form of a circle. Again, your book might use a slightly different terminology, but I like the expanded form because, again, I think it's more descriptive here. Now, find the expanded form of the circle with center -1, 5 and radius 7. Okay, this is exactly the same circle we considered in the previous example too. Okay, so if I give you a problem like this, here's what you want to do. You first want to find its center and radius form. Now, we already did that, right, in example 2 there. So that was x plus 1 squared plus y minus 5 squared is 49. Okay, and then your second step here is to expand and gather like terms, etc., writing it like I have in this boxed form above. So let's go ahead and expand this. Let's go x plus 1 and square. We get x squared plus 2x plus 1. X minus 5 squared is y squared minus 10y plus 25, and that's 49. Okay, so let's gather like terms and get 0 on one side, right in descending order. So we've got square terms first. I also like to use alphabetical order. So x squared before y squared, okay? But we've got x squared plus y squared. And then we've got first order terms. So we've got 2x and then minus 10y. Again, x is before y's. And then I've got 1 plus 25. I subtracted 49 on each side to get 0 on this side. And this boils down to x squared plus y squared plus 2x minus 10y minus 23 equals 0 if I did my arithmetic correctly. And that's our final answer for that question, so I boxed that in. Okay, in a follow-up video, what we're going to be doing is taking things like the expanded form or the center radius form, and from those, we're going to try to find what the center and radius of the circle are. Okay, that will involve some techniques involving completing the square again. Okay, well, I hope you understood all this. Shouldn't be too bad. Okay, hope you listen to the next video.